For those of you who are ready, this is the Incredibuild session, and we are going beyond build distribution today. So we thank you for joining. So let's kick this off here. There we go. So welcome to the Incredibuild tooling track. We appreciate you joining us to hear and learn about Incredibuild. I'm Beau, I'll be your host. I'm a solutions architect here with Incredibuild in the US, helping customers to go incredibly fast. And joining me is Avi Lachmish. Avi is a software development director who designs and builds the software that lets you go incredibly fast. So some of you here today may already be familiar with us or have been or are using Incredibuild, while others are brand new. The design of our agenda is to give background to those who are new, but also show additional functionality that those who are using it may not be aware of. So we really have three parts today. We're going to set the table, the why and what are we doing. We're going to talk about the development acceleration platform and discuss how Incredibuild works under the covers. And finally, how can you use the platform? Plus, for some fun, we're going to be showing you the tools in action today. There's 3 separate demos. So, and since this is an online session, if you have any questions, please put them in the QA chat. We'll be happy to review those and get some answers to you. And with that, let's get rolling. So why are we here? We're all builders. It's in the title of what many of you do daily, right? The definition of develop is to work out possibilities of or to create or produce, especially by deliberate effort over time. And that last little bit is the key to everything of why we're here. It's an effort over time. Time is what you need. In our interconnected world today, if there's one thing that everybody's demanding of is your time, and they want more of it. And Benjamin Franklin famously once said, lost time is never found again. So building today's modern applications is all about speed. Your end users and customers are wanting the next features. The business is setting deadlines against you. And when you think of an idea, you code, you debug, you compile, you wait on that compile, you drink coffee while it compiles, you brew more coffee waiting for it to compile. Then you realize you're out of coffee while it compiles, right? It's the same thing of what happens is you're burning time. You need results so that you can do those additional things. You know, you want to be able to have QA do their testing, and your customers are still waiting, of course. So as developers, we get it that you're under pressure to get things done faster. At the end of the day, you love what you do, but let's be honest, when your box is saturated when compiling and you're just waiting, it's not really a good thing. You want a tool that can give you back time, and a tool that can get you on things you want to do, to work out those possibilities, to create, and as we said, to produce better code. So software development tools in and of themselves are not a new concept, right? They can help you be productive, but you need to ask what makes a good tool. Now, if I was sitting here in the room with you, I would have asked for a show of hands, but you can think about it. How many of you have heard of Rube Goldberg? He was a rather interesting man. He was an engineer, an inventor, and an author, but he's really probably most famous for his depiction of simple tasks being handled by complicated gadgets in an obscure and intricate way. And these affectionately became known as Rube Goldberg machines. Now, this cartoon here is the self-operating napkin. I always like this, kind of humorous, where you say, I'm working clockwise now. How it works is you raise your spoon, it's going to pull on the string, which is going to yank on a ladle. That's going to toss a cracker over the head of the parrot. And that parrot makes a ruckus getting to that cracker, disturbing a seed. Seed falls into the bucket. Bucket gets heavier, thereby opening the lighter, and it lights the fuse. Now that causes a rocket to take off, which pulls the sickle, cutting the cord. And now your clock's pendulum is released, ultimately having the napkin swipe back and forth. It's 13 steps for a simple action. And it is humorous, but in reality, not probably a great tool. So 13 steps to wipe my mouth, a lot could break or go wrong, and all I'm going to do is get soup on myself. And Rube had a very interesting comment. He said, the machines are a symbol of man's capacity for exerting maximum effort to achieve minimal results. So at the end of the day, you don't want a tool that is overly complex and causes you more effort in setting it up and maintaining it. You're going to want a tool to have a minimal effort to use and yield maximum results. So with that in mind, what you say is a good tool should do several things. One, it should solve a problem. Not every problem, right? We don't want to boil the ocean, right? If I need to get my compilation times faster, I don't want to try building on a bunch of different things inside that one tool. I want to solve for my compilation times. The second thing is I want to be simple to use. Now, there's always going to be configurations. Not every design is going to be push button, single Google entry, or an Apple just push this button. But Do you really want to have to compile the kernel every time you want to use your OS? Or when you're eating soup, have to go find a parrot? The tool should be straightforward to use and not soak your time setting up, maintaining, or resetting every time you want to use it. If you are, then the tool isn't solving a problem, it has become your problem. And finally, for the third thing that'll make a good tool is a flexible integration and an agnostic method of consuming. So technology is constantly changing, right? You may have on-prem systems today, and then tomorrow you're operating in the cloud. Your CI/CD software systems could change. If that's the one thing we can say is change is a constant. So a good tool is agnostic and can be stitched in at the right spot in your process. You don't want to change your other tools, processes, or methods to use it. So with those three characteristics of a good tool in mind, let's look at what Incredible's philosophy is on how we're designing our tool and the capabilities you're actually going to see today. So for solving a problem here on the left, well, it'd be great if we could solve for War and Peace, right? But we only have 60 minutes, so that's probably not going to really happen. But if you think about it, a fun fact is Tolstoy's War and Peace, the average reader will spend over 37 hours reading the book. And that's at an average 250 words per minute. Statistics are fun, right? But do you ever feel that your compile times are reading War and Peace? Everything is about speed. It is the new currency. I mean, it's even in our developing method, right? We talk about sprints, not brisk walks. We focus on solving the problem of time, giving you the ability to go fast and accelerate your development cycles. Some use cases we accelerate are compilations for C++, shading, rendering, visual effects, static code analysis, and even your pipelines. The second thing we want to do in our philosophy is be simple to use. So regex, right? I'm sure many of you have seen this little funny before, but is there anything that can be more muddy? I mean, I've had an entire class just on regular expressions, and yet every time I'm still on Google. So our philosophy is in simplicity of operation. We'll break down Incredibuild's architectural components here in just a few minutes, but everything is packaged in a single binary. And that's going to provide all the components you need to distribute your workload. From install to accelerating and distributing your workload, it literally can be done in minutes. Management is designed to be handled centrally, so you don't have to touch a billion machines. We even will give you visualized feedbacks to see how your builds are running or have run. And without a doubt, we're still parrot free. Lastly is being seamless. So Incredibuild is going to be agnostic to your environment. To be fast, you need simplicity. To have simplicity, you need to be seamless, and how that tool can be happily plugged in to your various methods of work, thus the happy plugs. So we designed Incredibuild to work across all different types of machines, regardless of if you're running on-prem or in the cloud or even a hybrid approach. Because of that design, integrating into your existing workflow, you keep and use your tools, processes, and methods. There's nothing you need to additionally configure or duplicate across what you will ultimately create with the Incredibuild grid. The tool is agnostic to what's on the machine. You won't need to replicate your source code, your libraries, software stacks, environments, anything along those lines. We're going to handle that automatically on your behalf. Now, these three elements of our philosophy is what we use to create the development acceleration platform. And that's what we're going to be talking about in this tooling track today. So let's break down how the platform actually works. Now, you can officially report to friends and family that you saw a UFO in Denver, right? The original founders and developers of Incredibuild, they had a problem, right? They wanted to solve and get their compilations to go faster. And the vision they had was the SETI project, but they wanted to make it for developers. Now, for those of you who may not be familiar with SETI, it's the search for extraterrestrial intelligence. You effectively say that they're looking for ET, right? But what they're doing is monitoring all the electromagnetic radiation transmissions across the solar systems and the planets, and they're looking to see if there's something out there that is uncommon, right? Not natural. So to process all the data they receive, they set up a grid of computers. And the foundation of what our platform does is allows you to go fast is to harness CPU power from other machines in the network to parallelize your tasks. So we knit together a supercomputing grid and then distribute the job across it. So at the root of Incredibuild is what we call process virtualization. Now, many people are probably familiar with the word virtualization, but what I want to call out here is it's not like VMware or Hyper-V where you're going to run the entire machine. Rather, it's just the process. So internally, there's a lot going on. but we make it simple to use. Our process virtualization is going to create a sandbox environment that operates in between the OS and the process layer to be executed on each machine that is running Incredibuild. Now, in this example, we have a build initiating machine, and by that, just say your laptop, and it's running Visual Studio. When you kick off a process, for the compiler like CLEXA, instead of being passed to the OS, we're going to intercept that. Now, from this point, Incredibuild will handle everything that needs to occur. The initiating machine obtains an available helper that you can see here on the left, and that machine is what we're going to consume the CPU resources from. So what happens now is the compiler is synchronized to the remote machine. And what we're going to do is emulate the structure of the initiator in that sandbox. So when the process is distributed, CLEXA is going to look for the source file that it needs to work. Now, the compiler thinks it's calling its normal WinAPI function to access the disk to go get the file, but because it's running in this sandbox, we're going to intercept that call and send the request to the initiator. The initiator is going to send that file to the helper, which is then placed in the Incredibuild folder structure. And a common question that's asked about this is, what about caching? And this is important. Yes, we create a cache on the helper. If the file existed before, we don't want to have to transfer it again, right? So to maximize our bandwidth, we're only going to transfer what that process needs in real time, if it's necessary. So if the compiler were to need access to, say, something like an OS system DLL file just to do its job, that's not going to be synchronized, right? We have that locally. So rather, we'll allow that system call through to the OS directly on the remote helper. But regardless, all of these actions are still transparent to the compiler. Now, the compiler does its processing and writes the object file, and then that's going to be synced back to the initiating machine. Any linking that needs to occur will happen on the initiating machine. So you don't have to worry about having a logged in user, privileges, sudo, run as, anything along those lines, as that agent is going to be running as a service. And the emulation follows our philosophy of being simple to use and being flexible, where you don't have to, again, replicate your environment. So as mentioned, you don't have to duplicate your source code, your compiler, your libraries, or anything else. You just need to run an Incredibuild agent on the helper. Now, this just shows one helper instance. The process visualization is going to handle that process execution, but how does it know what's available? How do we scale and create a grid? And well, those are the great normal follow-up questions. And so let's look at the core architecture. So to slice up that processing that we talked about and take the tasks and then distribute them to make you fast, you have to have the grid. And if you step up a level from what we were just looking at from the virtualization component, now what you need to do is create that with three simple components. One, there's an initiator, right? You can see it labeled here as a dev machine. The initiator is just that. It's the machine that will start the build. And like I said before in the example, you can think of your laptop or a build farm server, right? The other thing is a coordinator. Now, this is what centrally manages the grid. You can see that there on the left in the upper right-hand corner, or upper left-hand corner. And a way to think of the coordinator is like air traffic control, right? So it knows where everything lives, what the configurations are, and what's available, what's busy. And then finally, you need helpers, right? Those are going to be the machines we said that have the compute resources that you want to make available for all of your processing. Now, the flow of how this works is fairly straightforward. The initiator is going to kick off the build. It's then going to communicate to the coordinator to get available helpers to distribute to, and then it's going to hand those tasks down. And then when the helpers are completed, just like we showed, when they get done, they're going to hand those completed objects back, and the initiator is going to perform linking and puts everything together. So it still goes back to be our philosophy is simple to use. This architecture is created from the same single binary. You choose the type of element needed to be installed on that resource machine. So whether it's the initiator, coordinator, or the helper, and regardless of what you choose, we still support a heterogeneous compute world. So resources can be anything from a physical server to a laptop to a desktop sitting under some other person's desk to a VM, etc. The coordinator itself is a simple web service. And for the initiator and helpers, it's a single lightweight agent with some open ports for communication. Now, we talked about a lot of things going on here, and one of the things that often we get asked about is, Well, what happens if that task or something has an issue during the processing? I lose the machine, right? So for example, developer laptop that's being used as a helper, and then that particular developer says, I'm done coding for the day, right? Because that never happens. And they slam the screen closed and they shut off the machine. You don't have to worry about anything there. We'll handle that automatically. The initiator is going to understand and recognize that the process that was being run just terminated and is going to go refire it on another helper. Now, that was a whole lot of information. But again, what we're trying to show is that there's simplicity of operation with the 3 components. We build the grid, we make you fast. Now, I personally I'm a Penguin guy. I've worked with Linux a long time, and I love Linus's quote about talk is cheap, show me the code. So really what we want to be able to do here is show you a demo of Incredibuild in action. Now, just to set the table, if you look on the right here on the screen, there's a standalone grid. I have 5 virtual machines. There's my coordinator, an initiator that has Visual Studio installed. And today's examples, we're going to be using the OpenCV libraries so that we can compile those. And then I also have 3 additional VMs available for use. Now, take that back to following our philosophy of being flexible in our design. The agent has also been installed on all the machines, so I can take advantage of all 5 machines being helpers. So that's what we're going to be doing today. And with that, let's switch over to our environment. So as you can see, we talked about we have our initiator and we have Visual Studio here. And at the end of the day, with the things that we're going to show you here as part of this process is how we can be set up. With Visual Studios, Incredibuild has native integrations. We have a very strong partnership with Microsoft, and we stay lockstep for their Visual Studio releases. And we have a plugin to where Incredibuild can be simply and easily used straight from the Visual Studio IDE. That you can do simple things such as your builds on your solutions, on your projects. I can come down here and I can look at the errors or warnings if there's anything. And I can even set agent settings on that particular machine. Or I can also tell the extension to have settings. And this is where some things can get interesting for you. So if you had certain things you were doing that were small, like, hey, when I just do my first build, I don't necessarily need to accelerate or use the other components or rebuild or clean. You can come in here and select all the different things that Incredibuild will intercept when that job is kicked off. So for instance, in this one, I don't have it watching for builds, but just the rebuilds and cleans, etc. Now in our environment today, thanks to OpenCV, it has a CMake, and then because of the way Visual Studio works, it obviously will automatically make that. So it has already set up my build environment for this, but we haven't compiled yet. So before I kick the build off, what we want to show you is the actual coordinator. So I know I already have integrated, and before I kick the build off, what I can look at in the coordinator is my centrally managed dashboard, if you will. I can see how many online machines I have, how many busy cores that might be running the builds. There's lots of just information that tells me, but what I'm really interested in is down here under the agents, and this is where my grid is. So you can see I have 5 here, and they're all listed as helpers, but I also have my coordinator and I have my initiator, which is simply called out here. Now there's lots of things I can do, and looking at this, I can drill down and see how much disk space or memory, some settings that the agent already has, just things that you may want to know about your grid and those particular components. And if I need to or want to, I can go to each machine and configure something special if I want. But being centrally managed and being simple to use, we can come in here and we can change what we may need to for our environment to suit our build needs. So if I want to select and say I want to create build groups, which is, say, an example of saying maybe I have a team that does light testing so they don't need as much horsepower versus somebody who's doing full release builds. Maybe I want to make them have the Threadripper machines or something along those lines. I can do various things of assigning priorities. There's a lot of different configurations that I can come in and set globally as I need to for communication ports or log files or things along that nature. So the coordinator is going to be your central control point. Now that's all fun, but let's see it actually in action. So if I come back over here, and again, we want to compile the libraries, what I'm going to do is I'm going to go ahead and have Incredibuild kick this off. Now, this is our build monitor. This is the visualizations that we give. And what this does is obviously, instead of you just seeing something normal like this that you might be used to, we're going to take that information and we're going to visualize it for you so that you can begin to really dive down and understand how your build is running and what it's doing at that point in time. Now, you say, well, these are all some really neat colors, and I can zoom down in here. Every single thing that you see here is just a process that's been distributed. And you can see all the different machines that I have brought online to help distribute that load. So instead of a 4-core machine, I now have 20 CPUs running for me. They're color coordinated to make it easy for you. So green means that the process completed correctly. The purple are things that are in action now. The light blue here are linking, because remember we said linking happens on the initiator, so you'll always see that up here. And then anything that comes in yellow or red is a warning, or red for an error. We also give you some system graphs, which really help you be able to see what's going on across your build. So like, for instance, this one, I can see that I have 20 CPUs assigned. I can see that I have 57, or at this point, 30 tasks that are waiting to be run, with 20 tasks actually running, because that's how many cores I have. But I can begin to watch and see what I need to look at for how my build is running. And I can back out, and you say, well, what's these white spaces mean? Well, again, these are the tool sets we're going to be able to tell you. So like, obviously, if you had, say, multiple projects and then there was dependencies underneath, Incredibuild is going to be smart enough to know how those need to be set up and when they need to be compiled. So you will see those breaks depending on maybe some of your project build or your dependencies. So there's going to be a lot of visualizations that you can see here. And then the other thing that the visualization will always give you is if you want to come in and see additional system graphs for something that is of interest to you, about how much was the kernel time running, or what's my memory actually doing on these machines, I can quickly turn these on or off as I so choose and get that information real time. Now, for this machine, when I ran the OpenCV library on the debug build, without Incredibuild on my 4-core machine, it took 9 minutes and 12 seconds. Now this should be wrapping up here in just a second after this little last linking. And there we go. I have a green bar. The green bar here tells me everything built successfully. And you can see that it took about 2 minutes and 40 seconds. I can come over here and look at a summary, and it says 2 minutes and 39 seconds. I know it might be a little bit hard to see, but with a RDP, it's hard for me to scale that very easily, but it says 2 minutes and 39 seconds versus the 9. So I've got about a 3.5 times acceleration rate already for those builds. And if I come back and look, I now have all my binaries. So that, in the nutshell, is Incredibuild, just doing a standalone distribution and accelerating your build, splicing it up and putting it all together. Now, the other thing I'll mention really quickly here is we can also save this off. So if you need to share this with another developer, you need to have somebody be able to review this and say, well, let's look at our build, what happened, let me check out the timings or anything along those lines. You can save this monitor off and then send it on to people. All right, so let's talk about being seamless. Remember, we want to be able to plug into how you need to operate in modern architectures, right? Which is going to introduce what we aptly named the Incredibuild Cloud. Now, as developers, you're just trying to get your work done, but your company's also watching its costs, right? I would love to be able to say we're all going to go buy a bunch of Threadrippers, but buying and maintaining additional hardware may not be an option, but you still need more compute CPU resources. So Incredibuild Cloud is a tool that's going to give you the ability to integrate with your cloud and then dynamically and optimally operate those cloud-based instances on your behalf. So the same components of an initiator, the coordinator, and the helpers are used. And now we're going to integrate to your cloud with spot instances. Now, we can utilize on demand as well, but there's a reason why we recommend spot instances, and that's for cost savings. For those who may not be aware of them, the main difference between an on-demand and a spot is that the cloud provider reserves the right to pull the spot instances back from you on very short notice. Think like 15 to 30 seconds. If there's resource contention in that provider's compute capacity. So because of that, what they do is the spot instances are offered at a very nice discount for you because they still want you to obviously use that spare capacity whenever it's available. So when you think about this and you use it strategically in an automated fashion, spot instances become very powerful and cost effective. And one thing I want to show you is when you do this, we have the cloud. And I'm going to turn this on so we can get this ready and going, but it's a very simple, easy to achieve process through the coordinator. And you want to say, well, how does it work though? Now the process is the same that we just showed in the core. Developer Debbie here is going to kick off a build. And that initiator talks to the coordinator, just like you saw before, and we're going to get 4, say 8 core machines. But let's say she's asked for more and you have like 64 total that you want to be able to use. The difference now is that we have the coordinator also interact with the cloud orchestration service that you see in the bright blue right up there just under VPC. That orchestrator is a service that we run that operates on your behalf by integrating with your preferred cloud provider to make API calls and automating the management of those compute instances. So again, you're not having to get in under the covers and manage it. When the request hits, we're going to check how many instances do you already have available versus what's configured to run. So in this example here, we have 2 instances that are hibernating, and those are going to get turned on. So because of the number of cores requested, we want a total of 4 cloud instances, say, to be started up. So that's an additional 2 machines. Now, in case of the spot getting deallocated, because it does happen, or if we need more power, we will fire up additional machines based on your configuration and place them in an instant reserve pool. So developer Debbie, she now has her cores running her build, but now, like we talked about, what happens if the cloud provider suddenly says, well, I'm taking your spot away from you? We're going to intercept that API call notification, and we're going to detach the disk so that you don't lose it, and then either pull from the pool, or we're going to instantly request new spots and reattach those disks and place them back into service. So the 2 things to remember here are, 1, if you have the spot deallocate, we're going to automatically handle the failure of that process. It'll be rescheduled on another helper. And the second thing is, if the types of spots that you configured, the number of cores that you normally ask for, aren't available and nothing is in the pool, Incredible Cloud will continue falling back to other types specified on your behalf until it finds the next available one for you to use. So for instance, if you've configured to use 8 core spot instances, turns out there's none available, we will fall back and look for 6 cores, 4 cores, you see where it's headed. And one last thing to call out is the orchestration is seamless. We talked about cost savings because the business is still looking for that, but you need your resources. So as a job completes, or fewer tasks are required, we will automatically move them back to the pool or hibernate to assist with those saving costs. Okay, now we have another demo coming up, but the cloud is killer. But I want to discuss one thing that's going to be a part of this next demo for talking about using modern software development, and that's CI/CD, right? Now, as you guys do this daily, you're checking out code, modifying it, checking it back in. And from there, a number of things obviously can happen where you could trigger a pull request, you could merge branches, I could kick off compilations, I could package. There's obviously a whole host of things that could happen after you check your code in. But at the end of the day, what we all realize is the more you continuously integrate, the faster you can find issues, correct, and release. So the Incredibuild tooling can be applied to this framework and directly plug right into your CI pipelines. Now, remember, a good tool should be seamless and agnostic, right? So we say CI generically. It can be Jenkins, Circle CI, TeamCity, the list goes on, but we're going to work the same. One that is newer, but it's been rapidly increasing in popularity is Github Actions. We've seen that coming out more. So for discussing Incredibuild, for the CI part, we're going to actually talk the use case of using Github Actions. So now, instead of developer Debbie, we have developer Dan, who just finished coding up, say, the Artemis flight navigation software. And when he checks in his code, the first step in the pipeline is to perform a pull request and merge that branch. The next step in GitHub Actions is a workflow is triggered and evaluated. Now, the workflow is a YAML-based file, and we all love YAML. And it's the component that defines everything about your desired job and what steps, the actions, it needs to operate on your behalf. The jobs and steps are where you're going to define plugging in Incredibuild. Now, in the earlier demo, in the first standalone, we showed you we have native integration with Visual Studio. But as part of being simple to use and being seamless, we also offer command line options for you when you need to integrate with other build systems, platforms, or other CI/CD. These steps are what's going to be is what's going to tell Incredibuild what it needs to do on your behalf with any configurations and modifications, modifiers that you need. So as you begin to see this, actions then are going to kick off and begin executing your job. Now from there, that normal flow that you've seen, we're going to go to the coordinator, we're going to get our resources, we're going to disperse, right? Those helping tasks are going to finish your play and then hand you back your completed build. Now with GitHub Actions, what I want to call out here real quick, if this is something just a little bit different, is they have two different types of runners. There's a self-hosted runner, which goes and actually installs on the machine of your choice where you're kicking the build off, so you're in your initiator. That is already going to have the Incredibuild agent running on it, right? Because it's an initiator. So that's going to seamlessly just pick up and know what it's doing. The second option is being GitHub hosted. Now with GitHub hosted, you would have an extra step of making sure that the Incredibuild agent would be installed in the runner or installed real time as the runner is spun up. No different from when adding packages to any type of CI runner. So like if you use Azure DevOps, it's very similar to that type of action. All right, so this is the second part. This is a lot of fun because now we'll show you the cloud. We're also going to show you how the CID works. If you look over again to the right, it's very similar setup before. I have my 5 machines that are my standalone. I've got Visual Studio. I've got open CD libraries still. Now I've added in the cloud orchestration service. So we're going to have spot helpers underneath the covers. And then we're also tied into GitHub so that when we do a pull request, it's going to handle everything that we need. So the first thing I want to come back to is look at the coordinator. And you can see here now I've got new machines. I've got cloud machines that have spun up on my behalf. So these are all spot instances that I have available to use on top of the original 20. And if we come back here, now what I want to do is I've got some changes in my development. And so what I want to do is push this up and do a commit. And if I do a quick git status, we'll see that we now have some files that need to be committed. And we'll do our little quick cheat here. And we'll make this a run number 4. Now, obviously, this is what you guys are used to doing. We're going to push this. It's obviously grabbing everything it needs to do and sending it up to the repo. And that's going to take just a moment. But as it does that, we'll check. That should be fairly quick. There we go. If I come over here and look at my repo, where I have the demo code sitting, obviously my compare and pull request hit. Now I'm going to go ahead and kick this off before we talk to the rest of the part, because there's going to be 2 parts, and it's going to have to do the CMake elements, and then it's going to actually start doing the build for me. So we know there's nothing really massively that we changed, so we're going to go ahead and do the pull request. We're not going to have any conflicts. We're going to merge it. Now, we just closed. If I come over and look at my actions now, my workflow, I have the Incredibuild trigger. And you can see that I have a test release runner 4 that we just committed, actually running and doing what it needs to do. If I click in here, you can see that it's actually started the build in the Incredibuild. You say, well, hold on, where did that all come from? We'll talk through this part. This is the workflow. What we have to do when you set up anything with the CI is obviously set your pipelines, your steps, and your actions that you want it to take. So we're going to name it. And with GitHub Actions, you can actually do quite a bit as far as what you can trigger on: a push, a sync, a pull. You can do things on filtered branches. There's a lot of things you can do. But on this particular one, what I wanted to have it trigger on was the pull request be merged and closed. So I know everything's fine. Everybody's checked out. The 2 things that we're doing then in response is we have 2 jobs. I need to build. So I want to run my CMake, and I want to get my solution, and I want it to do it on the x64 release. And then once this is done, I actually want to have Incredibuild go out and build the binaries for me. So we're going to check the code out again. And this here is the main thing I want to call out. This is where instead of integrating, we're going to give you the command line. So now you can easily choose how you want to be able to run. If this was some other make tool, if you had make instead of CMake, or you had some other build system like Ninja, you can create what you need to here and just wrap that with our command line. So this is what's running right now, and it's going to take it just a few minutes to do this. It usually wraps up here fairly in about 2 minutes, and then it will start running Incredibuild, and we'll pull that here in just a second. And while that's doing that, make sure there wasn't any Q&A that hit at the moment. No open questions? Always good. And the other thing I can do obviously is drill in as I need to see things and confirm that CMake did what it's supposed to. And I can also confirm that more simply just by coming over here and looking, and now I have my release. Now, as that completed that step, you'll notice we've gone to Incredibuild. So now that it's completed that build, that was a requirement to have. And now this is going to start actually running and distributing it across my grid. If I open up my build monitor, you're going to see a couple different things. One, this is going to have optimization, so it's going to run just a little bit longer. So we may come back to this. But without Incredibuild, doing my release build takes just shy of 18 minutes. I've been averaging right now a little right around 4. So I'm getting, what, 4.5, 5 times the acceleration onto my release. But again, you're getting the same steps with your build visualization. So again, you can see exactly what's going on, drill down into things. But the bigger thing we want to talk about is as I scroll down, I'm also consuming the cloud. So now my cloud is assisting in this build and we're distributing out. And instead of the original 20, if I look at my coordinator right now, I have 48 cores now. So I've doubled my ability to process and expanded my grid. Like I said, this will take just a few minutes to complete. So we'll come back because there's one thing that I want to show you when this does, but I'm sure nobody wants to sit here and watch for another 2.5 minutes while we do our actionable items. And since there's no other QAs, we'll switch back over and can carry forward. So we're getting close. So right now you've seen how Incredibuild accelerates your development cycle by distributing your processing. Right, we've done this on your standalone or your on-prem. We've added in the cloud, and we've integrated your CI/CD pipelines now, so you can embrace automation in your DevOps practices. There's still one thing, however, right? So we took using our example of developer Dan and developer Debbie. They've heard about shifting left. Now, most people here are probably already familiar with it, right? Traditionally, you think of building software from a left to right phase. You analyze, you plan, you design, right, and you wash, rinse, repeat. And traditionally, that testing has been later in the process. The issue is we obviously want to increase how fast we can build and deploy code, but we still want high quality. So we want to be able to catch anything that might be a vulnerability earlier. So the question is how do you handle that? Well, Clockwork is a very popular static code analysis for C and C++, right? And Incredibuild will integrate with that as well. So the issue is Clockwork is a very compute-intensive process. If you haven't used it, there's 2 steps that it needs to perform. First, it needs to create a build spec. And in that phase, basically what's happening is Clockwork is going through and documenting and tracing things internally for its own usage, right? It needs to look at what the dependencies between components are and all those types of things that it needs to understand what it has to look at. The second phase is then run, and it's going to pull in all that trace knowledge that it just built. And it's going to run that against its analysis for best practices, what may not be, give you the results. That's known as an integrated analysis. So you keep hearing fast, simple, and seamless. You're going to use the same tools, process, and methods, and we provide that tool to perform distribution and acceleration, right? And we're going to be able to accelerate both of these phases, again, with the command line opportunities and capabilities that we have. So in our example here, we're going to do very quickly. Developer Dan is in phase 1 has a Clockwork job that wraps the Incredibuild process, meaning Clockwork is going to call in to us, and then we're going to handle and distribute that build specification on its behalf. Now, once this build has been completed, Clockwork's going to generate an output file, which ultimately has all of the information, all that analysis, all that tracing of what it needs to analyze. And in this case, in this one thing, it just says OpenCV build spec, right? You can have it be whatever you want to actually name it for the output file. But what we're going to do in the second phase is add that and flip the process. Now, Incredibuild is going to distribute that Clockwork project on your behalf and distribute that build out. So it's just reverse, but it's still using the same command lines that we provide. And then once all that's been loaded, it's going to run its job, do the same process flow that it did before. And then once it's loaded, that analysis is going to come back into the Clockwork server, and you're going to be able to review the recommendations at that point. Now, real quickly, this one is much shorter, but we're going to show you how this does. But on the Clockwork, what we want to show you is exactly that. Here I have the Clockwork process that's going to be using its setup and the OpenCV modules, and it needs to do all of these different things that it needs to look at: concurrency test, memory descriptors, and then it's going to run this KW inject command. But here's where we call Incredibuild on that solution so it knows what it's actually doing. So Clockwork is wrapping around Incredibuild at the moment. And very simply, this can be run possibly if I didn't double click. Let's try this again. There we go. So we're having Clockwork now kick off. And what you're going to see, if I open the build monitor, is initially Clockwork is doing its preparation. And then in just a moment, it'll actually run and begin its integration. Rebuild all started. Like I said, Clockwork is an intensive process, which is why you definitely want our ability to help you roll faster with this and distribute the workload. I think when talking with the developer who set this environment up, when he was doing benchmarkings, the first couple things were running around 45 minutes to do the build analysis. And we were getting it down to say 11. And sometimes depending on the actual integration analysis, that was, could take a little bit longer. But at the end of the day, you can see now we're bringing on the grid, the additional cores, and we're actually starting to run the analysis. And at the end, when it did complete, what you're going to get is loaded up into the Clockwork UI itself. So now I can begin to look at the different things that it may have found. And that is the simple way of how we can begin to accelerate Clockwork as well. Now, one last thing I did say I wanted to revisit with you was if I come back over to the initiator, you'll notice I talked about how things could be green, yellow, or red. In the release, we have a yellow, we have a warning. Now, oftentimes you sit there and say, well, if I want to dig through a whole lot of code, how do I know where it was? How do I be able to find it? With Incredibuild, because of the visualization tool and the way that we understand and mapped everything through the processing, if I double click, it takes me right to where that particular warning is or that particular error. So again, we're going to help accelerate not just your builds, but we're also going to help you accelerate and find when those things come back, maybe that one a little bit pear-shaped. And in this one is pretty straightforward. It just tells me that in this particular file, I've got an argument that's doing a conversion from a bool to an integer. Obviously something we want to check out because we could use data loss, right? So we're at the summary. You've seen a lot today. I appreciate the patience. And so we're just going to do a quick wrap. At the end of the day, you as a developer need to save time. You have many options in your tool bag. But again, what we talked about is you want a great tool that's going to solve a problem. It needs to be simple to use and allows you to be flexible. So Incredibuild follows that philosophy and solves your time problem by accelerating your development cycles. So your C++ compilations, your shading, your visual effects, your CI/CD, static code, those things that we showed today, you're going to go faster. You can achieve 3 to 5 to 10 times faster builds depending on how you may configure. It's simple to use with a single install binary. It's native integration with Visual Studio. We give you command lines. So if you're using other tool sets that are not Visual Studio, say like Unreal Engine, or we're going to give you that capability to do that. We're going to be managed centrally. We're going to give you those wonderful visualizations so that you can see what's going on with your build. And of course, there's still no need to buy a parrot. So finally, we're seamless, agnostic and generic, and integrating with your framework. It's your tools, your process, and your methods, regardless of if it's on-prem or in cloud. We will integrate and make you fast. So I don't think there was any more questions. Looks like we're okay with that. So I think with that, we're pretty much right on time. And with that, I want to thank you for coming and attending our session. Hopefully you were able to get some good understanding of Incredibuild, what we do, and enjoyed seeing in action. We're at CppCon through this Thursday. So if you'd like to learn more, you have other questions. In fact, even several of our people are going to be presenting. In fact, Avi, it has some sessions. Please go attend his. You'll learn a lot. But if you'd like to learn more specifically just about our tooling, please stop by the booth in the main hall. We'd love to chat. And thank you again. We appreciate it.